Hi, I'm Jeff Morris, and today we're going to talk about understanding the issues that surround the need for handling distributed workloads. So when we really start to investigate the problem of needing a distributed workload support, uh, they may manifest themselves as a variety of different things, right? It could be a lack of productivity from an application because it's too slow, or lack of ability to support different geographic locations because it's only hosted in a particular availability zone or cloud. Um, in many cases, there's a lot of situations where the root cause of all of this is, slow application, right? A lack of partitioning or data balancing, lack of high availability support, lack of cluster scaling if you're operating in that style of deployment. And maybe you just need a lot more resiliency to support a large user community. So I'm going to break down a lot of what these particular issues end up looking like, and why you need a distributed database like Couchbase to help support applications that are indeed distributed in nature themselves. So what does a distributed workload mean? It means that, workloads themselves are the applications that you're running. And, applications are workloads in many cases. In environments, databases are workloads. And the problem with all of these is, those computers, the networks, the hard drives, the wires that you're using, the electricity, none of that is actually truly reliable. Right. But you need these things to operate, all the time. You want a 24/7 operation in many cases. What is distributed workloads? There's a great website, scaleyourapp.com, that describes all of this. So the way we look at it, and as database developers, right, we recognize that computers themselves, and everybody's should be familiar with the three core elements of a computer: the CPU, the RAM, the memory of the computer, as well as the storage. They all have limits, as does the network that you're connecting to. Also has particular limits in terms of throughput, or whether it's on or off. And applications, in many cases, regularly exceed the limits of each one of these different dimensions. So in the case when a computer loses electricity, right, it goes down. So we want to scale for availability and make sure that, the system is always on and it's always available. Now, you might have heard of the nines, the 4 nines or 5 nines that of availability. 4 nines of availability is about an hour a year. And 5 nines is about 5 minutes of downtime a year. So the way that we look at that is HA and Couchbase means that, at least one cluster node is always going to be available to receive and offer data to and from the database. So if something ends up failing, we typically like to have a backup copy of all that data in the cluster and replicate it to other nodes so that it can indeed take over if the primary node fails. Fault tolerance, of course, is, be able to do that, what I just described. You have a failure, but you can recover from that, or you can absorb it and not lose availability, right? One node isn't fault tolerant at all, right? If it goes down, everything stops. 2 nodes can accept a single failure. One node can go down and the other one can operate on a temporary basis. But if that goes down, then you've got trouble because nothing's available. And 3 nodes can accept 2 failures at a time. And you'll see a lot of configurations take on a 3-node availability kind of model. So for DR, right, you want to do the exact same thing, disaster recovery, except have one of the nodes or some of the nodes, or even perhaps a whole backup cluster, be available on a different site. And that's how you absorb a catastrophe, right? A physical catastrophe in the environment. So again, because of course, computers fail, but so does, the power goes out. I live in California, earthquakes hit. All of those things are contingencies that you have to plan for. Now, I want to also characterize something, a unique, interesting capability of Couchbase is this multidimensional scaling. So each one of our core services here, the query service, index, data, text, search, eventing, and analytics, all of those can actually be independently scaled by themselves within a cluster. That's what this diagram shows, is index and query search, eventing, and analytics are each scaled across 2 nodes, and the data services scaled across 3 nodes in this 13-node cluster. So the whole design of Couchbase is to be very, very tunable in terms of performance in meeting the needs of the application for any one of these services. So the other issue, so we covered kind of the machine availability, but now let's talk about storage availability and what happens if the database outgrows the hard drives that it's stored on, right? Then you need to break the database apart. That's called sharding or partitioning, and every data item needs to end up following the same sort of principle as the server does. So we automatically shard, and I'll tell you about that in a minute and how we actually do it and what's clever about it. So we use a thing called a cluster map, which tells your application where its data lives. So app server 2 here is looking for its data. It's on server number 1, which is the active main read-write node for that particular server at that particular moment. But any member of the cluster in there can actually take a write or a read from any one of the app servers that are up there. And the reason why they can do that is because the cluster map tells them, informs them, even before they ask any node where's the data, where the data happens to be. So they always know where their data resides. There's no extra lookup that is required in many cases. Our in-memory consensus-based replication is really, really fast because it happens in memory when we're moving the data around and putting it all on these 3 different nodes and replicating across them. And we actually can process all of this at the collection level, which is an organizing structure in Couchbase, so that all the data stays in sync. Then take that principle, and then we also offer cross-data center replication, so we can do geographic replication from cluster to cluster, regardless of where that cluster lives on the planet. And the other fun thing is we can also sync down to mobile devices in and out. And even mobile devices can sync among themselves if they're on a common network, but maybe not even on the internet, right? But they happen to be, the network happens to work in the house, but the internet is out all over town. And you can still have devices synchronizing amongst themselves. So when we evaluate or really start to talk about these replication styles, whether it's replicating data within a single cluster, that happens really fast, as I mentioned, so that all nodes in the database are aware of what particular updates have taken place. This can be transactional, so you can say, execute transaction and roll it back. And then cross-data center replication does a very similar thing, but pushes the data over to another site, whether that's in a different continent or perhaps just a different zone or data center. So, and replication can be bidirectional. You can also filter it. So if you have data sovereignty issues that you need to take care of, XDCR will do that. So when we really look at like how we handle different situations in supporting distributed workloads, this is how we do it, right? When we look at application availability and slowness, we've got this high performance clustering design where everything happens in memory first. When we need to roll over the database and actually add capacity to the storage, we can automatically rebalance all of that data and redivide it amongst new storage drives. If you don't have geographic replication, cross-data center replication solves for that. And if you have a lot of latency within the distributed network, setting up extra clusters that are closer to where the users are is typically a good idea. And then multi-site resiliency has got to be designed in. So we have backup services that run alongside or within every cluster, so that you can always make sure that you've got a cold copy of everything of all of your work. So when you're looking at this, really ask yourself, what's the most critical data? What kind of geographic support do you need? How are your applications designed for availability and fault tolerance? And how much time and energy are you spending on managing all of these things, right? How much resources are you dedicating to the cloud operation, the cloud management of making sure all the components are working together? For all of these different types of developers, right? How much time and effort are you building availability into your application when it could be actually handled automatically by something like Couchbase? how much energy you're spending on managing that object relational mapping kind of thing. All of these are situations where handling distributed workloads is a key requirement for applications, and Couchbase helps solve for that across a variety of capabilities inside the database. So thank you very much. That's our discussion about handling distributed workloads as a particular application problem.